Okay, this is page 3 of the Geometric Sequences series problem set. And again, unfortunately, I recorded this whole video with no sound, and now I'm going to do it again with sound, so that's why everything's written out here. Sorry about that. Okay, first problem. A geometric sequence has all its terms positive. So what is that telling you? Well, now we know that if they say all the terms are positive, what they're really saying is, hey guys, R is positive. Okay, because when R is positive, you multiply by the multiplier, the answer always stays positive or always stays negative. It never changes. When R is negative, what happens is every time you multiply by R, it flips the sign of the term. It goes from positive, negative, positive, negative. So in this case, what they're saying is, hey, R is positive because all the terms are positive. The first term is 12, and the third term is 48. So we're going to write down what we know. U1 equals 12, U3 equals 48. Now, we're going to write the term formula for n equals 3, which would be U3 equals U1 to R squared. Why R squared? Because the exponent here is n minus 1, n being 3. Okay, now we have U3 we know is 48, so we fill in 48 for U3. U1 we know is 12, so we fill in 12 for U1. And then R squared we don't know, so we leave R squared. Now we're going to divide both sides by 12 because we want to isolate R squared. So we get R squared equals 4 because 48 divided by 12 is 4. It looks like I wrote 0.2 here, but that's actually messy writing. Okay, now when you have R squared equals 4, the solution could be 2 or negative 2. How could it be negative 2? Well, negative 2 squared is also 4. So when you have 4 equals R squared, you don't know if it's 2 or negative 2. In this case, we do. Why do we know? Because they told us R is positive. So we know that R equals 2 and not negative 2. Now we take another term formula, which is U12 equals U1 times R to the 11th, because we know that because they want us to find the 12th term. And the 12th term would be U12 equals U1 times R to the 11th. Why 11th? Because it's n minus 1. R here, or n here is 12. Okay, so U1 is 12. R is 2. We found the R was 2 right here. And the exponent is the 11th. And so you just put this in the calculator and you calculate it out. 12 times 2 to the 11th. Make sure you use parentheses here. Okay, next problem. A geometric sequence has first term 2 and the third term 32. Find the common ratio. Okay, we just used the term formula. U3 equals U1 R squared. Why R squared? Because the n is 3, n minus 1 would be 2. Okay, we know that U3 is 32 because they just set it up here. And then we know that U1 is 2 because they just set it up here. So we know 32 equals 2 R squared. Now we're going to divide both sides by 2 to isolate the R squared. And we get R squared equals 16 because 32 divided by 2 is 16. If R squared is equal to 16, what's R? Well, it could be 4 and it could be negative 4. Now, did they tell us at any time that all the terms were positive? No, they didn't. So now we know it could be either 4 or negative 4. So now we need to calculate the rest of the problem, always thinking that the answer could be 4 and could be negative 4 because they've never told us it wasn't negative. Find the sum of the first 12 terms. Okay, the sum formula is S12. So we're going to write out the sum formula. S12 equals U1 times quantity R to the 12th minus 1 divided by R minus 1. Now we're going to substitute in R equals 4 for R. And we're going to substitute U1 equals 2 in for U1. And then we'll do that in our calculator. We'll figure it out. Now, what about the case where R is negative 4? Well, what you're going to do is you're going to do the S12 formula again, except for this time you're going to use R equals negative 4 instead of 4. And then you'll get a totally different answer. Okay? All right, so the number 2 actually has 2 possible answers for A and 2 possible answers for B. Okay, another word problem. Word problems, remember, you have to be careful because n might not be what it seems. Okay, in a word problem, you also have to usually find the multiplier. It says that the value of the car is 75,000 GBP, and each year it loses 8% of its initial value. What's the multiplier? The multiplier is not 8%. Okay, if you multiply 8%, the car would lose 92% of its value in the first year because all that would be left is 8%. The multiplier in this case, you would take 1 minus the percentage being 0.08, okay? Because what's happening? You're multiplying by 8%, and then you're subtracting it off the original value, and if you do that, it's the same thing as multiplying by 1 minus 8%. 1 minus 8% is 92%, or 0.92. Okay, so the multiplier in this case is 0.92. When the car is new, it's worth $75,000. At the end of the first year, it's $75,000 times the multiplier, which is 0.92. At the end of the second year, it's $75,000 times 0.92 squared. At the end of the third year, it's $75,000 times 0.92 cubed. Do you see the pattern now? 3, 3, 2, 2, 1, 1. Okay, so what about for the end of the fifth year which is what they're asking for? Well, then you're going to have 75,000 times 0.92 to the fifth, okay, because that's following the pattern. All right, so and if you notice, the pattern is not the same as, like, if I was going to say, oh, that's U5, so U5 is equal to U1 to R to the fourth. If I compare that to what I did here, it's not the same. Why is that? Because the exponent I'm using is 5. And why did it turn out that way? Because actually, the end of the fifth year is actually U6. Okay, and the first year is $75,000. So actually, do you see here? There's 1, 2, 3, 4, 5, 6. Okay, so that's why it doesn't really work out. You can't say, oh, n equals 5 because it's after 5 years. No, actually, after 5 years, it's the beginning of the sixth year, so that would be U6 and not U5. But the easiest way to do it, in my opinion, is to make a table like this and then figure out how much it is every year, and then figure out, just with the pattern here, what exponents you're going to use. Because you can see here, 2, 2, 3, 3, 4, 4. So you can see the pattern is that the exponent is the same number as at the end of the year n. Okay, well, in this case, it's not really n. Here is another word problem, so we're going to do the same thing. The good thing about word problems is usually the number of years involved or whatever is not a large one. So you can write out the whole table, and it doesn't take up that much space or time. So it says lottery price is 10 Bulgarian currency in the first week, 20 in the second week, 40 in the third week. So we write down, we're going to write that down. 10 first week, 20 second week, 40 third week. And it continues to double for a total of 10 weeks. Okay, so the first week, U1. Second week, U1 times R. Third week, U1 R squared. How do I know that? Well, first week is U1, second week is U1 times R, because I'm multiplying times the multiplier, okay, which we know is 2. Okay, and so that works out, all right. And if we go to the 10th week, we know that our formula for the term is U1 R to the 9th. Okay, but then we look here and it says find the total of prize money. It's not looking for the amount in the 9th week. They're looking for the total amount, or I'm sorry, the amount you get in the 10th week. They want the total amount, which would be S10. The total amount of money from the first week to the 10th week. And we use this formula and we plug in n equals 10. And R, of course, is going to be 2. And U1 is going to be 10. And so you just put that in your calculator and you're done.